Hello, good morning. This is Professor Khan, and this is EST-103 Energy System Lab 2. And this is week 4, Lab 4. So far, we did install primary control for Lab 1. Lab 2, we did primary control and an aquastat. And Lab 3 is going to be primary control and aquastat and a switching relay. And this week, we'll do a stack mounted control just to change things up. Then we're going to go back to doing the take-home control with switching relay and primary control. Okay, let's get on with this. It's going to be a very short and sweet lab, but I want to get you introduced to the stack-mounted control for two reasons. Reason one is they are still out there. You might see them in some boilers and furnaces, and even though they are kind of being phased out, but the technology and the mechanism of having stack-mounted control is still used for a lot of heat sensing in hot air. So the name stack mounted means it's mounted on the stack, which is mounted on the chimney and the flue pipe. So it senses temperature. You can mount this as well on the duct to show you to indicate the heat and so on. And it has a bimetal kind of mechanism in it. It's supposed to be replacing the CAD control cell. It senses heat instead of light using a bimetal, so it expands with heat. And if you guessed it, it will take a lot of time to sense heat and expand than to sense the light in the fire. The safety timing for a stake mount control is 90 seconds. It's very, very low. It's double what the CAD cell used to be 3 years ago. Now the requirement is 15 seconds to sense the light and the flame, otherwise the system should shut off. The location, again, it's in the stack, so you you have to install that right from the stack coming out of the boiler. They are still in operation for old models and they are grandfathered in, so if they are there, you can keep installing with the same one. But uh, if you if you have the option, you should change that into a CAD cell system. But sometimes not even possible for all models. You have to change the entire boiler, and you will discuss that later on. They are not for operating for more than 1,000 degrees Fahrenheit. You might ask me, well, where would I find that? It's there are some boilers that can run this high and they're with this high temperature, but it should not be exposed to this much temperature. So the maximum is around 600, which actually does happen in oil. Again, they're being phased out slowly. This is what it looks like. It has two relays here. This is the stack where it goes inside. The stack goes inside the flue pipe, or you can put that also inside a duct system. And this is the push button to change the switch. And if you look here, there's a thermostat. I mean, there's a transformer, and whenever there's a transformer, we are transforming 120 volts to 24 volts. So this is going to, you guessed it, to the TT terminal, which is the thermostat. There are four connections here. And if you notice something as well, there are barriers here to keep things separated in terms of temperature and what are you going to connect and to keep these covered the whole time. So again, this is supposed to control the ignition and the burner motor and by the input coming from the thermostat. So they have some of the service required for these model stack mounted primary controls. What can go wrong with it? The terminals can be a little bit dirty because they have a lot of hot air going through it and sometimes some accumulation of soot. So you can clean that. You can make sure the contacts are clear. These contacts in here, they can accumulate some rust or residue, so you can clean those. You can check the low voltage and the high voltage, make sure it's getting the right amount of voltage, and also you can check the safety timing for the motor and the ignition if there is no fire. And again, it's going to take around 90 minutes. That's a minute and a half to trip and tell you there is no fire. That's very long. Okay. Uh, Going back, this is the reset button. And if you look at this lever here, this is how you put the system in step, meaning it's ready to read the temperature. You pull on this lever and let it go. And this should reset those contacts. There is a set of contacts in here that go one after the other, and you have to see it to believe it. To be honest, it's not really clear here. And if you look in this little stack here, this is the bimetal part which expand rapidly with heat. You can actually see it expand. We will do that in the lab. We will point a torch at it and see it expand, and you'll see how it will connect those contacts in here. Very mechanical, very basic, but again, it's very susceptible to damage a lot. Over the time, this metal gets really brittle and it will break, and you can change that little piece of metal. It does work, but the problem with rust, and if you move it, you actually hear it like crackling and creaking because it's metal being exposed to heat. So it's very old-fashioned, and you might see it in the field sometimes. So it's good to be exposed to that. This is the connection, and the wiring schematics looks a little bit overwhelming, but these are the relays that we are going to see. Those are the two relays actually we saw before. These are the connections for the thermostat, and these are my terminals. One of them go to the hot, two of course is neutral, and three will go to the burner motor, oil valve, and four will go to the ignition. To make things simpler, if I just cover the nonsense in the middle, I will just look at the terminals outside and what needs to be connected in there. This is the same thing, wiring with the thermostat. This is a different wiring. Is it the same? I don't know. I think it's the same wiring, but let's look at it again. Hot coming in here, and three goes to the oil valve and the motor together, and four will go to the ignition, and everything will go back to the neutral. And I don't know why is this jumper. Oh, I think this is if you have a 3-wire thermostat. Okay. Sequence of operation: thermostat will call for heat. The ignition, oil valve, and burner motor will start. Safety switch will begin heating. The bimetal expands. Then it will open the contact to close the open contact in the control will close. Ignition will de-energize. It will drop. The ignition is not constant ignition, so it does have this capability. And once the call for heat ends, means the thermostat will open the switch. It will drop off operation completely. So it's very, very simple, and connection is very straightforward. But I know they're being phased out, but I thought it was very important for you to know how they function. And so if you look at it, you'll be like, okay, what is this kind of relic? But it is still in operation. Safety lockout, 75 cents on average. It could be more, it could be less. So again, it has to be reset manually. How do you reset it? You pull the bimetal and let go, and it should come back into end step. It's ready to do the sequence of operation. Simulate flame failure. See what happens if the flame fail. Would it respond? Would it not respond? Simulate ignition failure, and also simulate power failure, meaning turn on and off the power and see what will the system do. Scavenger timing is the open and close of line switching, meaning that how long will it take for the switch to open again and to go back after it's being expanded. Like if the bimetal expands and you turn it off, how long would it take for that to go back into the first location? I think that's what they mean by scavenger timing, and it's a very common terminology. Troubleshooting, again, as usual, if we want to know if thermostat is at fault, we jumper it. If you jumper and it works, then it's not the thermostat. You go to the next step, clean the contact. Does it work? That's good. If not, you move to the next step, jumper both thermostat and the normal close contact, and clean the bimetal and the contact detector and the metal detector again. Does it work? That's good. If not, then we'll move on to the next one, which is replacing the bimetal. If it doesn't work, just replace the entire primary control. It's also called the primary control because it does control the burner. So we have a CAD cell primary control, and we have a stack mounted primary control. Here's a video from the gray furnace guy. He's really great, and he does a really good job explaining these things. I think he's a national treasure, by the way. So watch his channel, subscribe to him. So I will see you in the lab, and we'll do this connection. It should be a lot of fun, and we will be able to answer the lab assignment as well. Thank you.